So good morning everybody, myself Acharya Vishvendra, and today I'm going to discuss a basic worksheet on the bind force. So let's begin with the worksheet. So here is the worksheet. First question is dimension of bind force. So it is a force, dimension is m1 l1 t minus 2, SI unit Newton, CGS dian, 1 Newton is 10 raised to power 5 dian. Bind force is, it is due to the pressure of the liquid. Now there is a question, a body is submerged into a liquid of density d1, density of body is d2, mass m, density d2, this. Then we need to find total volume of the body. So we know that volume is mass by density, so that is m by d2, and it is also equal to V in plus V out, where V is in is the volume inside liquid, V out is outside liquid. Mass of the body d2V, bind force on the body. So bind force is density of liquid into volume of solid inside the liquid into G. Then if lift accelerates, then bind force will be replaced G by G effective. Next is, in this question, lift accelerates upward, so F bind will be, you replace G by G plus A. Here replaced by G minus A. In case of free fall, bind force will be 0 as G is equal to A. Now if we refer to the stationary case, then we need to find the bind force. So we assume that this thing is stationary in equilibrium. So net force is mg, that gives V in is equal to d2 by d1 into V. Next is, if lift accelerates upward, will V in change? No, V in will not change, and that's a very important question. Will V in change? No. Fraction of solid inside liquid, so that is V in by V, which is d2 by d1. Now next is percentage of solid inside liquid. So for finding percentage, you just multiply fraction by 100, so that will give d2 by d1 into 100. Now next question is fraction of solid outside liquid, so that is V out by V. V out can be written as V minus Vn by V. On solving this, we get 1 minus V in by V. Next is percentage of solid outside liquid, so percentage is fraction into 100, which will be 1 minus Vn by V into 100. Next is, will V out change if lift is vertically accelerated? No. V out outside or the inside will not change, because pressure will change itself and it will adjust itself so that the body is again in equilibrium. So there is no change of inside or the outside volume. Next is, out of bind force, apparent weight and fraction out and in of solid in a liquid, which parameters will change with acceleration of containers vertically? So the parameters are the bind force, the apparent weight, they will change accordingly, but the friction inside or outside will not change due to acceleration of the lift. So that's a very important question, very important concept.